So, hello everybody. Yeah, I'm sorry. Quite a lot technical problems. First of all, Mr. Ron maybe can join us on the 14th of December if you want to participate. The next one is that I give tomorrow a talk at our career day. And yeah, what I will do is I thought about it on the weekend, and yeah, I dealt just in the beginning with especially ChatGPT when it came out in November last year, and then unfortunately I did not that much the last month with it. And 2 weeks ago I sat in a train, and opposite to me was a student, and we talked to each other, and yeah, he really showed me what you can do with artificial intelligence, especially in your studies in the education sector. And I would say he really used it in a good manner, in a way how you should use it. And therefore, my idea is that I'm doing more or less a live experiment tomorrow, so that more or less I try that ChatGPT is giving my lecture or my talk. Well, we will see what happens. I will do also a talk not about only about ChatGPT, but other tools. I recommend it for you, especially the translation software behind this is, of course, also artificial intelligence. And due to my topics, I would also add, mathematical software and something like this. Well, we will see what happens tomorrow. So if you want to join, I want to advertise myself. Then some organizational part. We will then do our talks on the weekend before Christmas, Friday, Saturday. So we will meet Friday afternoon in Jever and stay overnight, and then the following day we will give the other lectures. This will be then a joint workshop with the guys from IBS who are doing their stuff from global economics, but within their topics they also had to do a linear regression, and so I think this will be vice versa. I think from the content be interesting for everybody. And I think yesterday I also said that the linear regression has a direct relationship to Jever, because this was a point of the measurement of the cartography of this part of our country by Carl Friedrich Gauss. Okay, I will put this also in the Moodle course, and then what I also need from you is your age, because this is for the youth hostel, then we pay different prices. I don't know where the cut is until 27 or so, I don't know. Okay, and then this is something new that the university is not allowed anymore to pay for the food. So this we have to pay separately. And yeah, we will see how we can organize it, because we get a direct, what is Rechnung? This invoice, yes. We get a direct invoice with the total amount we have to pay, and then supposed to be we have to pay the dinner to the university, and we will see how we can manage it. I don't know. It is quite complicated. But anyway, and yeah, maybe we find also some time to go a little bit around in a city. Okay, then back to our topics. Yesterday, yeah, we, so to speak, go to real data the other way around. That I started, yeah, or that we created together a somehow realistic time series where we said what kind of components could we have within our time series, and then in the end we would have something like this down here. That we think more or less about a model, how our time series is developing in time. And yeah, we created here a model with 8 parameters, and then we would feed in these assumptions about the model. How does the function look like? And then we would start to yeah, try to fit the parameters in the right way, that they hopefully closely fit our data. And this again can then be done. I think this was not here. I thought I have shown it to you, or it has not, was not saved. That more or less we make an assumption that our model looks like this, and this would be then our data. And compared to the linear regression, now we have a general function, and again we would start to, in order to fit these parameters, we start to minimize the sum of the squared distance, now not with respect to a line, but with respect to some general function. And then you can think of that the minimization process is not trivial anymore. If you remember when we minimized the sum of the squared distances with respect to a line, this we could there we found a closed solution. This were then these huge formulas for the parameters A and B, or in general then these matrix inversion. And there we also, in the linear case, we have the problem that matrix inversion is not trivial anymore. There you already have to use approximation methods. And now if you think of that, you have here some cyclical components, sinus, exponential functions, and so on. All this you have to take the first derivative, setting this to 0. And in general, of course, you won't find a closed solution for this anymore. Even in this theoretical way, as we have found it in the multilinear regression, where we could solve it theoretically via the inverse of the matrix. Even such a theoretical solution you won't find a closed form for this anymore. And then, of course, this is done with the computer via the software package that we just program some iteration process so that we get closer and closer and closer. And this is then done, or actually in the end can only be done in finite time with some help from the computer. Okay, but now back from these quite complicated things to more simple things. But at first, I'm a macroeconomist. So where do we find these kind of time series? If you remember my macro introductory course, I showed you the time series of unemployment. And there you have more or less all this, that we have more or less the business cycle over time. So a long cycle, and then we have then within 1 year the seasonal component of unemployment. And well, of course, this can you then try to identify with econometric methods to find out what is the small cycle and what is the parameter, what is the volatility within a year, and what is the long cycle, the business cycle, and there the volatility. Okay, and if you then have an idea what amount these parameters have, then you can use this, of course, in order to forecast your time series with the assumption that you say, well, in the long run, the parameters you have fitted are not changing in time. Then you can, of course, make with your model a short run forecast. Okay, and now let's say simple forecast methods I want to do with you in the end of this lecture. So then, let's say we have quarterly data of revenue of some company, that this is the development over time from 2018 to 2022. And what we can do and what has actually a quite high relevance in economics is the more or less simplest forecast you can do. And this I call the weather forecast. What will be the weather tomorrow? Well, let me have a look outside. The weather tomorrow will be as it is today. And this is just the repetition of the last data point you have. Well, why do I have said that this is highly related to economics? Where do you find actually this assumption to make the forecast? So that the expected value where do we find the assumption that, so to speak, the best choice we can do, or the best forecast we can do, is that the expected value of tomorrow of x is xt, so this is t plus 1, the expectation operator for tomorrow. What do I expect for x tomorrow? And that I set this just to the value today, xt. I think you had some lectures about investment and something like this. Maybe you have also although you are studying tourism, think of TUI or some very large touristic company. They are doing then, of course, not only touristical stuff, they are also investing. And investment is done via capital markets and financial markets. And actually, what in theory think is if we have a complete, fully competitive financial market, then this is the best choice you can do about what are stock prices tomorrow. So this holds for fully competitive financial markets. This is the so-called efficient market hypothesis. Well, remember, what is economics all about? It is about prices. And what are prices? Prices are the signal of scarcity. So what do we think? Where do come these prices? So these prices are again, and about this we talked a lot in this lecture, prices are aggregating information. And what we think, if everything functions well in our markets, is that within a price or a good, or in financial markets, a price of a stock represents all information you can find in the whole world about this company. Well, and this in the end then means that on average it is impossible for you to beat the market. You cannot perform better, because if you are performing better, then you have more information, and this contradicts the assumption that all information is already in the prices. Well, and if you make this assumption, then theoretically you come out that prices in financial markets follow a random walk. And this is the so-called Brownian motion. Have you heard about this? Sometimes? So what we just assume is that we know, again, something, what I introduced here, that we know about something about a general trend, and that around this general trend, our price is just fluctuating randomly. So that the probability that an up and down is just 50%. And this was found in the beginning of the 20th century, that just such a process we find in physics when you are heating a stick. So think of it that you have a stick of some length, let's say 1 meter, and that you apply here a heat source, and then metal, something like this becomes hotter and hotter and hotter. And this starts from here and moves to the right. And this process is just a random process. So you have a general trend that it goes from left to the right, but within you have also always you have only random steps in between. Well, and then in the 60s, 70s, this idea was applied to financial markets. And actually, the first idea about this was in the end of the 19th century. But there was some misspecification, um, and so it wasn't possible to really fit the data. And then 80 years later, they made it was only a slight modification of the ansatz, and then they fitted very well the movement in the financial markets. And this then means that random walk, again, this follows just our normal distribution. And then you in general can show that you can describe such a process just via this condition. If this condition holds, then you have a random walk. And yeah, in practice, then we see quite often some deviations, but this is maybe then again due to the central limit theorem. Everything in our nature then approximately can be described by this normal distribution. Actually, in financial markets, then we have to assume that the price changes are not distributed normally, but the logarithms of this are distributed normally, but this is then some other special case. So in general, we can think of everything in the end follows the normal distribution. Well, and for this, actually, although this seems very stupid or too simple, this is highly applicated in the practical issues. Well, what you maybe have already heard of is that we then go further. Well, let's not feed in only the last data point, but let's feed in some more data points from history, and this is called moving average that we then say, and this we already have done when we talked about averages. Then I said I look back some period, say 4 quarters, 6 quarters, 8 quarters with my within my example, and then I just calculate, given this sub-period, all averages of all 4 quarters, and this I move just forward in time. And this then, so to speak, and this we will do in a minute, then means that we smoothing our data, because you can think of that in time you can have special outliers. Something really bad happened to your company in 1 year, and therefore you have really a large downturn, but on average in the last 5 years it was only one outlier there. And if you calculate these moving averages, then you are smoothing out these outliers. And yeah, then when you are calculating these averages, then you, of course you have to take your average and say this average is now a number for some point in history. Well, and there a very natural way to do it is just to say I take an average of an odd number, let's say 5 quarters, and then I say, okay, this average of the last 5 quarters is then the representative of the middle quarter of these 5 quarters. And this is then called, this new time series is then called centered moving average. Well, we can also think of that this is a representative for the first quarter of my sub-period, or that it is a representative for the last quarter of my sub-period. But in most cases, you use this because this is quite natural to say that I take just the middle of my sub-period. Okay, then let's take our data and we want to calculate moving average and then forecast our first quarter in 23. And let's do it for n is 1, 3, 5, and 7. So where's my data? There. Oh, this is a bit large. This is better, and let's increase the size here. Well, first of all, have you done in other lectures moving averages? No? So, let's go into our formula. So we say the next data point is just that here, if we feed in here for I, the last point in the sum, the h, then we need in the end xt minus h plus 1 should be our last point. So, and I think 1 we can skip. This is just the simple forecast, of course. Then let's try it with 3. And this means the next data point here is just the average of the 3 last data points. So what we do is then here taking the arithmetic mean of these values, moving it down, and then just in the end for 2023 Q1, this would be then our forecast, would be then 515 So this is just the average of these last three numbers. Well, this would be 3, or h is better. H equals 3, h equals 5. Not very hard to do it. The average of the last 5 numbers. You see it here. Moving this forward. And if we click in here, then you see it's just the average of the last 5 numbers. And h7 I want also h minus 7. And this would be then here is of the last 7 numbers. Well, and what we see here is that we are anyway, that we are coming down with our forecast. Well, let's see where this maybe in general comes from. And for this it is always a good choice just to look at the data. How does it look like? And oops, where we are. There we are. So, and well, if we just by eye look at our data, then we see, remember, linear regression, and our eye is a quite good calculator. So what would we do if we should have to put a line within these data? Well, I think you would also say that we would put here a slightly increasing line within our data. Well, and then, of course, it is not very surprisingly that if we are moving backward or increasing the number we feed in our averaging process of moving averages, then going further into history means that we keep more lower values within our averaging process. And therefore, of course, we should not be very surprised that the longer the time period we use, the lower is in general the forecasted value we have. Okay, and now I want to show what we mean by smoothing the data. This would then mean that we use this value here not as a forecast in the end, but this is 3/4 average. So then we would use this 355 as a representative of the middle of the period we have looked at. So we would use this number then as a representative related to the second quarter of 2018. Well, this calculations I had already done, so I just copy them downwards, and well, then we have, so to speak, the problem that our new created time series cuts off not at the last quarter, but a quarter before, since we have to step one quarter back, since we use here 3 quarters for the averaging process. I think this is quite clear. And also for 5 periods, not for 5 periods, for 5 quarters, this would be this one, and then we have to go 2 quarters backward, and for 7 it is 3 quarters. And let's add here moving average. Oops. Okay, and now we feed in this into our diagram, because here we see some, let's say seasonal pattern in my time series, and let's see how we smooth out these seasonal adjustments if we take the method of moving averages. So again, this one is, no, this is the name. This is then this one, and X is again the time, and Y is now our time series with moving averages, and the other ones too. This one, X, and this one, and the last one, 7, X. Well, and here, let's cut this axis to 300. Let's start there. Then we see a little bit more, and 550. And let's also change this to this one. So the blue line is our original data, and what you see then is, if we go down, the orange is H3, the yellow, no, the green line is H5, and the yellow is moving average with 7 quarters in the period, and then you see that the volatility is going down because we just averaging out of our time series these outliers due to the seasonal pattern we have here. And this is then, so to speak, a very simple method in order to find out what is the long-term increasing trend we have in our data. And in this is, of course, also a company interested. We are interested what happens in the next quarter, but we are also interested, well, from history, so what is our long-term trend? Okay, well, the first time I did it when we had Corona times, so there's also some question about this. Well, and then of course, if you are doing this, you have to think also what is a so-called good period to average our data. Well, and remember in the high times of the pandemic, then we looked always at some number of new infections lower or higher than 100 per day, I think. And this, the Christmas markets are starting next week or something like that. And remember, there was in Wilhelmshaven, was in 21, one of, I don't know, maybe 10 cities in the whole of Germany who opened their Christmas markets. Well, and then they had to close it also some days later, but they opened. And this was more or less then due to the averaging process, which was behind this. And in general, we looked at Corona data with 7 days moving average. And this was then the number we looked also officially. And then the city had to decide, are we going in the deep shutdown or not? So what is the idea behind this? Why not 10 days? Why not 5 days? Why not 11 days? Yeah. Yes, and this is not seasonal, but it is then. Right? Yes, great. So we have, of course, then something like a seasonal pattern within a week because we are doing similar things on Monday, Tuesday, going more out at these days than at others, and especially then around the weekend. And for this, it is a good way then averaging just for these 7 days. Well, and then anecdotally, because I plotted these data in these times, and I looked how do we obtain the data, and there we had to admit, actually, if one would have done it in the right way, Wilhelmshaven would not have been allowed to open the Christmas market because we had a time lag in Wilhelmshaven to collect the data of about 3 days compared, for example, to the official data collection in Oldenburg. They were quite faster to feed in all the the data from everywhere where you get it from. And this was known that we have this time lag of 3 days. But, well, they ignored it and said, well, let's open it. So this is also then a case of manipulating data. Okay, but 11:43, okay. Yeah, let's end then in order to discuss this forecasting method. Well, this is, of course, a good thing in order to, keep out then these outliers. And this is maybe then also a better method than if you are doing your bachelor thesis and you are asking some people about some tourism trend or so, and then some guys are answering some really weird things. And then you are sitting at your data and you think, whoa, how should I explain this now in my thesis? And sometimes you then start to qualitatively take out these extreme data points, but please be really careful in order to just skip data which doesn't fit in your ideas, because this is not doing statistics. Statistics is doing, this is my data, and with this I have to work. But moving average is then, yeah, an okay method in order to smooth down these outliers, for example. But of course, this we also have seen, if you also by eye just identify a long-term increasing or decreasing trend, then you are underestimating or overestimating your data with these more moving averages. Of course, then these seasonal effects, well, we came down with it, but it would be, of course, better in order to tackle directly these seasonal effects in order to identify something like a cycle. And yeah, this is actually very often done for just, yeah, as a rule of thumb for a short-term forecast if you don't want to use a very sophisticated methods. And this you really find widely applied in economics and also in steering your company or whatever. Also in order to forecast how many tourists will come and whatever. Okay, then we will see on next week. We, yeah, exponential smoothing, I think we will also can do, and averaging, this you know from macroeconomics, and in the end, we will deal directly with seasonality. I hope we will manage this then on Monday, Tuesday, and this will then also be the end of the official lecture, and the last part is then your talks in, yeah, about a month. Okay, thank you.